Welcome and thank you for joining us today for Modernize NetOps with business-aware network monitoring. My name is Raleigh Gould and I'll be moderating today's event. Our featured speakers are Seamus McGillicuddy, VP of Research covering network management at EMA, and Keith Sinclair, Chief Architect at FirstWave Cloud Technologies. Seamus has nearly 2 decades of experience in the IT industry as an industry analyst and journalist. At EMA, Seamus is the Vice President of Research, where he leads the network infrastructure and operations practice. With a rich career spanning over 3 decades in the ICT sector, Keith is a seasoned technology executive, renowned for his customer-centric approach, innovative mindset, and adept problem-solving skills. Keith currently serves as a chief architect at FirstWave. And before I hand things over to today's featured speakers, I wanted the audience to know that you can log your questions anytime using the Q&A functionality. Also, today's event is being recorded and you will receive the on-demand playback in a follow-up email from EMA. So I hope you'll check that email out. And now I'd like to go ahead and turn things over to today's first featured speaker, Seamus McGillicuddy. Seamus.
Thanks, Raleigh, and thank you everyone for joining us today. So we're here to talk about how you can modernize network operations with business-aware network monitoring. We'll talk about what that means, especially Keith later on. He'll go into a great detail about it. I'll talk about it as well. But first, I want to set up the context for why you need to be thinking about this and why you need to be modernizing your network operations approach as an IT organization. So first, I want to talk about why network operations teams, in my view, are struggling right now. And this is based on research that I conduct throughout the year, every year, surveying thousands of IT organizations about their network infrastructure, their network management practices and tools. And I talk to dozens of people on a quarterly basis on that topic as well. So I try to keep my finger on the pulse of how enterprises conduct network operations, and that's what I'm going to present to you here. First off, network operations teams seem to be in steep decline in terms of their effectiveness. At least that's what my data is seeing, and anecdotally, I hear it from a lot of people as well. Every 2 years, I ask this question as part of a biennial network management benchmarking study that we do called Network Management Megatrends. Last time we asked the question was last year. We'll be asking the question again in a few months. And the question is, how would you rate your overall success as an organization in conducting network operations? I may have worded it differently in the questionnaire. I can't remember the exact words, but anyway, we asked that question over and over again, and you see in 2016 and 2018, slightly less than half told us that they were completely successful on that mission to manage, monitor, troubleshoot, operate their networks. In 2020, it declined to 35%. That was pretty steep. And then it declined further in 2022 to 27%. So something's going on, right? That's concerning. And so a lot of my research over the last year or two has been geared towards understanding why that's happening. And you see some quotes here from people I've talked to one-on-one about this topic. A network team manager at a Fortune 100 pharmaceutical company told me, our network is one of the biggest in the world. We have hundreds of people maintaining it, and yet it's a tremendous mess. Still a tremendous mess. No matter what we do, it's a tremendous mess. Hundreds of routers that don't comply with golden config, lack of visibility, you name it. Network engineer at a Fortune 500 software company says NetOps is not super effective. I've seen big companies that just don't put enough investment into the people in their network operations centers. So people is an issue, and we'll talk about that in a little bit. And then a network engineer at a Fortune 100 consumer goods maker. If we're going to measure our NetOps success against critical incidents, we're doing okay. But if we're going to measure it against low impact incidents, I'd say no. And what he means by that is that at any given time, he has 1,000 open tickets on his network. and he can't close them because he doesn't have time to resolve them. But he lets them remain open for long periods of time because he knows they're not affecting huge chunks of his business. Why? Because no one's calling him up on the phone and saying, things are on fire, fix this. So he's just focusing on what he identifies as critical incidents, fixing those, keeping the network up and running. So why are we seeing this? One thing that's been a true constant, but I think just is getting more exacerbated as complexity increases in recent years, is that network operations teams are too tactical with their tools. They will buy a tool to solve a problem. And if you do that over and over again, you end up with more tools than you have screens, more tools than you have people in some cases. That's not effective. So 61% of NetOps teams in our most recent research tell us that they're using 6 or more tools to monitor and troubleshoot their network. That's a lot of swivel chair analysis. Like, I'm looking here at flows, I'm looking here at metrics. There's my log tool, tells me what's coming out of the logs. I'm using something from my network security team to understand firewalls. Maybe I'm using a couple open source tools because they do something better than any of the commercial tools that I can afford. Blah blah blah. It goes on and on and on. And based on our analysis, the higher number of tools that people are using to manage networks, the more likely they're having manual errors take out some or all of their network or degrade their network in some way. So that tells you that they don't really understand how they're making a lot of manual errors, but those manual errors are often, they might be, just like a fat fingered thing, but it also might be because they have such poor end-to-end visibility over their network, they don't understand how a change might impact health and performance. Also, with all this tactical tools strategy, those tools get noisy. 53% of alerts coming out of tools in the average NetOps group, the average NOC, Network Operations Center, are just false alarms, not actionable. This NOC analyst at a Unified Communications as a service provider put it well. He says, we don't know which alerts to check out, so we have to check all of them to verify that they're false alarms. That's painful, and it leaves your people with very little time to get anything else done. Like, if they have a report to generate or some new tool to implement, or maybe some updates to thresholds in their monitoring environment, that's not going to get done. So also, we ask people, what are your biggest pain points with your network monitoring tools these days? And you see the top 4 responses here on the right. Limited scope is the big one, the biggest one. I can't monitor everything I want to monitor. And that gets back to what I said earlier about people buy a tool to fix a problem. Hey, I just started using, we have SD-WAN now, and I need to be able to monitor it with a third-party tool. But the tools we use don't support our SD-WAN vendor. And we don't know how to use the APIs. So let's buy this tool because it supports it out of the box. Another situation might be we've gone into the cloud. We need to monitor the cloud from the NOC, and nothing we have can do that or do it well. So let's buy another tool for that. So yes, limited scope is a constant issue. It also might be a situation where I can monitor certain vendors' hardware well, but not other vendors because my tool vendor doesn't play as well with this obscure vendor that I have in my network. Difficult to implement. I often hear from people who focus on tool engineering, the people who implement and maintain tools, that they often don't have enough time to fully implement a tool. A lot of tools will take 6, 8, 12 months to fully implement, especially if you're migrating from one tool to another and that old tool had lots of customization around alerting and stuff, and you want to have the same level of alerting in the new tool. So you spend all this time implementing it and learning how to implement it because maybe you haven't used it before. And a lot of times the tool engineering team will come back and say, you know, we only had time to really implement 20% of the functionality in this tool before I'd move on to our next project, which then leads to more tool fragmentation because when it comes time to leverage some of the other functionality in that tool, it might be that the CIO is not aware that the partially implemented tool can solve a problem, and he just directs his organization to buy a new tool that could have been superfluous. That's basically superfluous. You just haven't fully implemented your tool. It goes on and on and on. Another 21% say our tools are too noisy. We already talked about that with all the unactionable false alarms out there. And then lack of insights. More than 1 out of 5 people told us lack of insights from our tools is a big issue. What does that mean? Well, I can see all this data, but I can't really figure out what the data means because it's all just, it's just presented in its raw form. Maybe my most skilled network engineering guys know how to interpret that data, but lots of my NOC analysts or my network operations engineers, my tier 1 people, they don't know what any of it means. Also, speaking of skill level, NetOps teams are struggling to find people and also struggling to retain the people they have. We asked this recently: does your organization find it difficult or easy to hire and retain personnel with network technology expertise? And you see only 13% said it's very easy, meaning only 13% say there's no friction there. 37% say it's somewhat easy. That's nice, but that somewhat caveat means that they are experiencing some difficulty in getting people and holding on to people. Like, it could be better, they're saying. And then you see more than a quarter of them are outright telling us it's painful. In terms of the skills they're struggling to hire, the big ones, the top 2 are network security and network automation. I need people that know how to protect my network. I need people who know how to, do Python and scripting and maybe use a network automation tool, commercial network automation tool. But then the other top 4 are, I need people who just know how to monitor a network and know what it means when an alert comes up. And I need people that can do troubleshooting, who can do problem isolation, root cause analysis, and like a hypothesis for remediation. Like, those are basic skills you want in a NOC, and also in a network engineering team, and people are struggling to find that. Also, at the same time, complexity in the form of digital disruption is happening. You have cloud fragmentation going on. I mentioned, hypothetically, that like people might need to point their network monitoring tools at the public cloud. Well, it's not just one cloud. 88% of enterprises tell us that by next year, they're going to be in at least 2, if not 3 or 4 clouds. And 91% of NetOps teams are trying to use their established tools to monitor that stuff, but only 18% say that they're fully effective at that. We also have IoT and operational technology convergence. People that are converging manufacturing systems, public utility infrastructure, oil and gas fields and platforms and things like that onto their corporate networks to at least some extent. 96% of NetOps teams told us they're seeing some of this, at least, and 53% of them told us that they have to invest in new monitoring tools to address the new gaps in visibility that happen when all this stuff hits their networks. WAN transformation is also highly disruptive to NetOps, and you'd think it would be otherwise, because SD-WAN solutions by definition come with a native monitoring capability that gives you end-to-end visibility into the network that your SD-WAN is deployed on. And yet 73% of enterprises tell us that they monitor their SD-WAN environment with third-party tools. And only 43% are completely satisfied with that tool support. Why is that? Why are they unsatisfied? Well, they have no end-to-end insights across the underlay, which is, the internet connectivity, the MPLS connectivity, maybe 5G or something else that wireless, like microwave or satellite. They aren't able to correlate that with the tunnels that the SD-WAN solution builds over the network. And inside those tunnels are all your applications, right? And so they can't connect what's happening with the applications inside the tunnels with what's going on in the network underlay, the actual network connectivity that you're paying for month to month under that SD-WAN environment. They can't correlate that. Poor reporting and visualization of those SD-WAN tunnels also. So like, not only can they not correlate between the underlay and the overlay, but they don't know what's in those tunnels from the third-party tools. And then data quality issues. Maybe they're connecting to the SD-WAN controller with an API and trying to pull data from that into their tool. And the data that comes out of it is garbage because it's highly proprietary, formatting issues. Maybe the data coming out of it is constrained in some way. So that's an issue. And then you have hybrid work, with 85% of enterprises telling us they've seen a permanent increase in the number of people who work from home since the pandemic. And only 31% of NetOps teams tell us that they're successful at supporting the networking requirements of those people. 96% of them tell us that they're budgeting for tool upgrades to address that visibility gap. So all of that is really painful. So what kind of advice do we see from the best-in-class NetOps teams in our research practice? Well, remove tool fragmentation and modernize the tools. So 77% of network managers told us that if they had a modern network performance management solution that had multiple functionalities, could correlate lots of data, that could provide lots of insights, that was good about noise, all those things, it would mitigate the skills gaps that they're struggling with, at least to some extent. Also, we're seeing that when people have a procurement strategy that focuses on fully integrated multi-function network performance, network monitoring tools, as opposed to like best of breed tools from multiple vendors, or suites of tools from one vendor that might be tightly integrated or loosely integrated, those that focus on procuring fully integrated multifunction tools just do better. So only 25% of all NetOps teams told us that their procurement focus on, when it comes to their tools, is to get that single vendor, multifunction, unified approach, platform approach. But 51% of successful network operations teams told us that that's our priority. So that shows you that the people who focus on a unified platform approach to tools are overrepresented in the group of network operations teams who are doing the best practice. But it's not easy. Network engineer and Fortune 100 consumer goods manufacturer tells us, we would like to have as few tools as possible, but no one can do everything we want. Okay, but can you find tools that can do most of what you want? Maybe you still have some point tools somewhere, but consolidate as much as possible. IT operations manager to one of the world's largest government agencies you can imagine, like bigger than pretty much, maybe the biggest. I haven't taken a poll, but I'm pretty sure it's the biggest. He says, we have a multifunction tool, but it won't scale to our environment, so we have to do several installations. We have more than 1 million devices. So yes, okay, scale can be a problem, but still, does that mean like you want to have one tool that just does one thing, monitoring 1 million devices? I mean, because that's a lot of data that you got to correlate. Like, okay, maybe you have to do several installations, but maybe you can do some integration at the console level, where there's like a report, like a BI engine or something that can consolidate insights across the multiple installations if you're that big. But that's one of the biggest networks in the world. I think most enterprises can find a way to make it work with a single platform, regardless of size. In terms of skills gaps, again, it's not just tooling, but it's also culture. Like, what are you gonna, don't put it at the top of your job posting, must be a CCIE, like that's gonna just not get you anywhere. Like, I want the very best certifications in this position, like the most expensive salary possible on the market. That's what we're going to hire for. You're not going to find those people, regardless of how much you pay them. It's going to be hard to find them and fill all your positions with them. So hire for potential, not for skills, not for certifications, but technical proficiency at a basic level. This guy that was at the very large government agency, he says it's important to have someone with a decent IQ and a willingness to learn. A good personality is way more important than knowing absolutely everything about the technology. You can train someone new and give them experience and responsibility and let them grow in the job, right? And then this network team manager at a Fortune 100 pharma company, I'm not looking for specific skills. I look for potential. I ask, what have you done with technology? Based on their answer, I believe they can learn to work with a new technology. We don't hire for top tier skills. We're just looking for general networking skills. Like it doesn't have, you can build your own expert. If you hire a good person, they're going to succeed. Another thing is like, what do you focus on in terms of measuring your success and achieving success? Like if all you do is focus on uptime and like enforcing SLAs, you're probably not serving the needs of your business anymore. The NetOps teams tell us that when we ask them like, what does success mean to you as a group? The number one response was security risk reduction, which means they need better visibility, make sure that all the network is compliant with policy and with golden configs and stuff like that, that changes aren't made without certain controls and checks in place, things like that. Change management is well orchestrated in your tooling, which isn't necessarily a monitoring thing, depending on the monitoring vendor you're working with, it might be. And then improving overall network visibility. So they have established that they can see everything that's happening on their network, and they see that as a measure of success for their team. That's something to strive for, instead of just trying to like see what data bubbles up and try to interpret it. Like get visibility, observability, as people talk about these days. Accelerated mean time to resolution, like how, things are going to break. Don't think about uptime, think about how fast you can fix it. And that means having good tools that can tell you what's happening. And then cross IT collaboration is also in the top 4. So how do we as a NetOps team formalize and execute on working with the other groups in our IT organization to make sure that we are delivering value to the business? So, and who are they partnering with? It's the security group, which makes sense given that they're really focused on making sure that they're reducing overall security risk. But it's also the cloud ops and DevOps teams. It's the Kubernetes platform teams, because a lot of people are modernizing their applications for cloud native environments. And the NetOps team is starting to think about how they get visibility into that and help support application performance on those platforms. Operational technology, we already talked about how a lot of organizations are seeing that converge onto the corporate network. So they need to partner with those groups, not just from an engineering perspective, but from a NetOps perspective as well. And then we see IT service management groups as a big priority too. So the people who own like ServiceNow or some other help desk ticketing ITSM platform, because if you integrate your monitoring tools into that, you're going to get a lot of good ticket automation, a lot of good process around how a network event gets handled by your IT organization. So that's something else that really focused on. So how to modernize NetOps tools. First off, successful NetOps people tell us that their teams prioritize these platform considerations. On this list, you see reliable data collection. So maybe they're de-emphasizing an SNMP MIBs and traps a little bit and using APIs or streaming telemetry to get some of their data. Maybe they're also getting rid of some proprietary parts of their network that didn't necessarily generate data that worked with their tools. Robust presentation and searchability of network data. So not just like lists of metrics and reports that show you like top talkers and things like that, but also the ability to like flip data on its head and see correlations between different data types, being able to click into things to see data presented in a different way, click on a map and see metrics, things like that, but also being able to search things with natural language to some extent, like, oh, show me switches that are have like 95 or interfaces that have like 90% utilization or something like that. Being able to search all that really quickly. Role-based access control, breaking down those silos. We see that collaboration is really important. It's some people talk about mean time to innocence still, but I really think you should talk about mean time to insight, meaning I'm not going to prove my innocence and point at someone else. I'm going to provide insight and hand it to somebody else, or let them come and get it with role-based access controls in my tool. Network compliance visibility, being able to see if some kind of config change happened on my network that is out of compliance, and also being able to say, like, correlate that with like an explosion of alerts on your network, like, oh, this went out of compliance, and then suddenly all these alerts went off in our data center. Interesting, that means something. And then APIs and integrations. Does your vendor have good APIs? Do they have an SDK around it? Do they have up-to-date and high-quality documentation around it? How much of the functionality is accessible through those APIs? Do they update those APIs every time they update the product? And can you integrate it with your other IT operations management tools, which might include security monitoring tools? Can you integrate it with the tools you use in the public cloud? Can you integrate it with your SD-WAN? Those are huge priorities. Also, diverse data collection. People are constantly telling me they're collecting more data from the network and more types of data from the network. And here you see it in chart form. Have any of the following types of network data become more or less important to the management and monitoring of your network over the last 3 years? Network device metrics. People have been collecting that forever, but it's getting more important somehow. Like, oh, SNMP, MIBs, and traps, but also API, streaming telemetry. Somehow it's gotten more important. Everyone's talking about melt data, metrics, events, logs, traces for observability. And the foundation of that on the network side is definitely network device metrics. Cloud provider VPC flow logs, hugely important to 64% of NetOps pros. That's all about trying to find better visibility in the cloud, not relying on CloudWatch from AWS, but actually pulling some metrics that are somewhat equivalent to maybe network flows, but not entirely. And maybe you can get even something better. But right now, a lot of people see cloud provider flow logs as a big opportunity. Speaking of flows, network flow records have become more important. Synthetic traffic, generating synthetic traffic on parts of the network you don't own, like the internet. SaaS providers, like being able to hit SaaS providers synthetic traffic, has become very important. Config data. We already talked about like config compliance and being able to understand how config changes impact performance. So it's very important as well. Network device events from syslog, even SNMP MIBs, from SNMP traps, routing data, even packet data, of course, everything. Topology data. It's all becoming more important. So you want tools that can collect all of it or as much of that as possible and correlate it, which leads to actionable insights with a service-centric network operations tool. Successful NetOps teams tell us that they have a tool that can generate alerts that are actionable rather than noisy. So the alerts might have all the data from like all the data related to that alert that comes from like other events, other conditions that might not necessarily be an alert from a tool that has a very narrow focus on the network, which speaks to the fact that they have tools that can correlate insights across diverse sets of network data. So flows, metrics, topology, being able to pull it all together to tell you how it's all related, presenting that in a way that's easily understood, or at least understood by technical personnel on your NetOps team, is very important. What kinds of insights are people looking for? Number one, they said they want security insights. So that a lot of times, for instance, like the security team will come to a NetOps team and say, can you show me what's going on with the firewalls? That could be an example of that, even though what they're really asking is like, are our firewalls allowing traffic through? Are they healthy and up, whatever? But it also might have to do with like, oh, well, let's see what you're seeing with network flows. I want to see if there are any suspicious IPs connecting to the network. Root cause to network problems. Obviously, that's very important, makes sense, but being able to present it in a way other than just like blasting you with data is very important. Application performance, especially important to very large enterprises. Being able to correlate everything you're hearing and seeing in the network, and connecting it with what's happening with your applications. Capacity. What's my network look like today? What's my network consumption going to look like in a month, 2 months, 6 months? Trying to figure out that can be very hard. Like most network monitoring tools have that today, but like how dynamic do they present the information? Can they see like patterns that aren't easily set up through like like you can set a tool to say alert me when I reach this percentage capacity on this interface, but what if like that percentage of capacity is a known condition that drops again within a day? Do you need that alert? Like, do you need that extra noise? And then finally, business impacts, which ties closely with the application performance. Like, which of my applications are important to the business? One network operations manager told me once, I might have 1,000 alerts on my network, but I only care about the ones that are connected to the applications that are critical to my business. I could have like 100 interfaces down on my network, but I don't care about them because they aren't impacting the business. I need to zoom in on the applications that are powering my business. And that means I start at layer 7, look at which applications are critical to my business, which ones are suffering because of the network, and then go down to like layer 3, layer 2 to figure out how to fix the problem. That's how he works. So how do you get to these service-centric insights, that these insights that we talked about that impact business, that impact applications? Well, successful NetOps teams tell us they prioritize 2 major things when they're looking at troubleshooting features in their tools. One, they want multiple metrics overlaid for time series analysis. It's very simple. Like what sort of patterns can you see when you overlay flows, metrics, events, config changes? It sounds simple, but if you can present it in a way that's very clear, it can be a game changer. Also, they want to be able to reconstruct network sessions, maybe like completely in packets, raw packets, if you have a system set up in the budget for it. Or maybe they just want to understand like what kind of conversation happened through flow records, like who talked to who, when, and how does that correlate with these complaints I'm getting about call quality or whatever. And then they also really want the ability to click to contextual information with one click. Just click a button, click an alert. 48% of NetOps teams said that they can get a report on all related events and network changes when they click on an alert. So that's great, but 77% of successful NetOps teams said they had that. So they're hugely overrepresented in the category of enterprises that can just click on an alert and get a report that says this is everything that happened that's related to this alert. That's at the very least problem isolation, and then maybe half the way to like root cause analysis. So key takeaways, and then I'm going to hand it to Keith. Technical tool strategies are unsustainable due to skills gaps, cloud, SD-WAN, IoT, work from home, and successful NetOps teams are procuring unified multifunction tools that collect and correlate diverse network data and translate data into service-centric actionable insights. So that's my mission statement for you. Now go forth and figure out how to do that. But maybe first Keith can tell you some more about how you can get there.
Bring up the slides. Wherever you might be in the world, good morning and good afternoon. I'm here in Australia. So we talk about business-aware network monitoring, and we see that as 3 key things that you need to be doing. You need real-time monitoring, proactive alerting, and actionable insights. Combining these together will give you a level that you can understand better what is happening with the business, how it's impacting the business. So what are the benefits of doing some business-aware network monitoring? So you're going to get improved business agility through better information and visibility. So you'll know when you can tell the business when something's wrong accurately, and when it, because you know what's wrong, when it can be fixed, and so forth. So the business can operate better. Enhanced operational efficiencies by increasing productivity. You're going to spend less time looking for things and finding them quicker, and that's just going to increase your overall productivity of the team. And then you're going to increase your customer satisfaction because that mean time to resolve, or the Seamus's mean time to innocence, I just heard that I quite like. But you're going to have a lot better customer satisfaction from reducing that mean time where a team's working on something to where it's resolved. So how do we get started with business-aware network monitoring? Well, I'd like to tell you that you could just buy a product and plug it in and turn it on, but that's not going to solve the problem completely. You do need to set up a bit of a project, and you do need some business steps and some technical steps. And I've outlined these here, on the screen. So on the business side, and this is something for probably the management team or the lead architects, or maybe a business analyst to come and help with. But you probably have the skills in your team to do this. You need to identify the stakeholders, and you need to identify the top business processes. Now, having done a lot of consulting work in the past, you want to look for those things that are revenue generating, legal or legislative need, or that's the core mission of the organization. So what are those things? And although companies may have hundreds and hundreds and hundreds of applications, often it's about 20 or 30 applications that are really, really fundamental to the business operation and profitability, or their function. So identify the key applications that are used by those business processes. Some business processes are going to be straightforward. It's going to be very obvious, like the accounting team will be using the accounting system. Some of the applications and business processes will be a little bit more complex than that. But don't forget to do your core productivity apps. Always make sure that you're including in that business visibility, email, internet, collaboration tools, things that people are using, all the time. You want to be monitoring those as well. So that's your business steps. Now on the technical side, which much of this can be happening in parallel, you're going to be discovering the network. You're going to start managing all of those elements. You're going to start monitoring the elements. You're going to want to establish a baseline, and that means using the tools themselves, as well as tuning thresholds and so forth, so that your alerting is right. So that adjusting baselines and adjust your alerting kind of go together. A bit of an iterative cycle there, but you want to get rid of that noise. To Seamus's point, you don't want these events going through to the operations team unless they can do something with them. So you want to make sure that they're not false positives, that you're delivering high quality events to the team. Then you want to be setting up your services. So that's your service monitoring and your business services. And then you want to set up notifications. And we're going to talk how and what that's going to do in a second. So before we go on to the things that you have to do, there's a couple of core concepts that are just fundamental to getting this right. There is no magic silver bullet. There's no silver bullet. You can't just fire this gun into the beast of the animal, or the beast of network monitoring, and solve the problem. You're going to have to do a little bit of work, and it's quite simple, but you're going to be looking at a few things around understanding the difference between shared and dedicated infrastructure. What's the difference between reactive, proactive, and business impacting? And then really, really critical is labeling devices with metadata. So let's go to that first concept. So really, you consider that outages are going to, in shared infrastructure, going to impact many things. Now, I've been a network guy for almost all my career, and as well as being an application guy at various times. But so when you have a network problem, it's going to impact a lot of people. Right, that's shared infrastructure. Almost always, network is shared infrastructure, especially a core network, a distribution network, or a building network. A switch going down is going to impact everyone on the floor, right? Whereas maybe a server going down is only going to impact the people who use that server. The disk gets full, server crashes. It's just impacting the people who use that application, right? Which is a much less, and that's dedicated infrastructure. So it's really, really important that we monitor the shared infrastructure as a service as much as we monitor the servers that run the accounting system, or the marketing system, or the sales system, whatever it might be. So now when you're monitoring that shared infrastructure, you can be telling all the people that use the shared infrastructure that there's something going on, and know pretty quickly through the sort of impact notification that what they can do. But this is the first really, really critical concept, and it'll probably become a little bit clearer as we just describe a typical business application in the enterprise. You've got users and a workstation. You've got a network in the middle, some kind of network. Could be the internet, could be metropolitan area network, could be whatever, large enterprise network. And over here on the right, you've got a front-end application. The front end, the application database, might be all on one server, might be multi-tiered and spread across the cloud, whatever it might be. But it's likely that these servers here are dedicated to that application, although the database might be shared. So now if we sort of overlay then what's in the middle between those things. So now we would look and say, well, there's going to be some, on the user side, there's going to be some switches and routers. And then on the server side, there's going to be some routers and firewalls and switches. And now we've sort of got a bit of a data center, maybe a bit of a small data center simplified architecture there. But those things there are going to be shared by many users, right? So lots of these applications. So now if we sort of overlay, then what does that look like? So everything here in the middle is shared infrastructure. All the users at this location are sharing this infrastructure. And then all the users, all the applications in the data center are sharing this network infrastructure in the data center. And you've got this dedicated infrastructure for these servers, right? So this is a clear visualization of seeing why and how these things are different, right? Something going on in the core network or the distribution network is going to affect all users. So now when we have that dedicated infrastructure, we have many, many applications running in our data centers. And now we just see that we've got, you know, lots and lots of things that we need to monitor on the servers there. That's fine. But it's just one set of monitoring we need to do for that shared infrastructure of the core network. Now, how would this work if you were just doing a network? So we've just sort of taken an enterprise network and simplified it into shared infrastructure. Where you're a service provider, it's the same sort of principle. Most service providers have this down pretty pat. But you have a core distribution, a network, and then you'll have dedicated infrastructure for different things that your services that you're then selling to your end customers. So this core network could be whatever the technology is, and there's so many new technologies out there. I'm not even going to try and mention them all, but you know, the classic one would have been years ago MPLS. You know, then people have gone on now to these, you know, switched IP networks, and there's all sorts of crazy stuff going on, which is great. But the point is, there's dedicated core devices, and then in each sort of region, there's distribution devices. And then you'll have dedicated infrastructure to then connect, you know, provide connectivity to end customers, right? So your core and distribution are your shared layers, and then those dedicated infrastructure, whatever it is, could be CPE, could be a bit more equipment on a customer premise, other switch equipment, so forth in the basement, whatever it might be. You've got dedicated infrastructure for a smaller number of customers. So it's the same. The way we build this and the way we look at it's the same: shared and dedicated infrastructure. Let's move on. I think we've bedded down that concept. So let's move on to reactive versus proactive versus business impacting. So what is a reactive event? So, you know, something that is going to cause something to be broken, right? So if it's down now, it's a reactive event and requires reaction now. So simple example: node down, disk full, application down. You have to act on those now. They require immediate action. And it's not something that you can look at tomorrow. It's something that you need to act on today. So we need to differentiate those reactive events from proactive events. Then your proactive events, something like CPU high, memory high, maybe you're getting early warnings that the disk is filling up, and maybe you're dropping packets on an interface. They're all things that require investigation, but they don't necessarily need you to drop everything and work on it now. You would put it into the queue for in ITIL problem management, or you might, you know, raise a capacity planning thing for the capacity team, whatever it might be. But that's those proactive events. So we've got a little bit of a simple map there, and you've got your action required. Is it reactive or proactive? And then you're just going to triage and restore the service as quickly as possible. If it's proactive, it's going to be investigated, and you're going to plan a change, an upgrade, removing load, whatever it might be. And then typically your reactive events are going to go to the operations team and the support teams. And the proactive events are going to go to the technology engineering teams and your capacity planning teams. So, you know, as soon as we break down, this is really critical. As soon as you break down that reactive from proactive, you're going to get a whole lot more productivity from the team. There's going to be able to, you know, people able to focus whose skills are. People are very skilled at reactive, and people are skilled at proactive, and they can both do each other, but it's a different mindset. So you're going to have trouble if you're trying to do both at the same time. But splitting them apart is going to give you a better chance for success. So now we need to understand what sort of action is needed. So let's drill into that a little bit more. So a device has many elements. Each of those elements, you know, have a status and metrics, and we roll those things up to device status. So the software that FirstWave have, you know, we talk a lot about state and status. So what is the state and status? Is it up? Is it down? And then, you know, what is the status of the thing? So has it got a fan failure? Has it got a high temperature? You know, some kind of status thing that doesn't cause it to be down, but causes it to not be as healthy as it should be. So some status events require action now. So maybe that fan failure requires action immediately, but some status events require action later. And then some events require action, state events almost always require action now. So now we can group those into those proactive events, reactive events, and we can also start to look at business impacting events. And we've got a bit more detail about that when we talk about enterprise services. So really, this is about getting all of that data coming out of your switches, routers, load balancers, VPN, SD-WAN devices, whatever they are. You're getting those events. You're reducing the noise. You've tuned the events. You've made sure that the useless events are not being done. You're dropping them, right? You're not generating false alerts anymore. Now you're grouping them into reactive events, sending them to the operations team. Proactive events, you're sending them to the engineering team. And then that business impacting events that you've identified, you're sending them to the customer success team, whoever that might be. You might be using different terminology. It might be your customer, your customer delivery team, whatever that team might be called. But you're sending those business impacting events to them, and they're notifying the people appropriately. So next step is labeling devices with metadata. Seems kind of obvious to me, but as I've worked with many organizations around the world, I don't know that everyone uses metadata well. And I think, AI and ML have really shown the importance of data labeling and labeling things. The reality is that humans work really well with metadata, and AI needs metadata to function. Like, it doesn't work without it. So labeling devices and having context so that you can correlate things better means you need better metadata. So now, based on what we've just been talking about, we know that all the devices aren't equal. We know that there's core devices who have more impact on the network through shared services than maybe a server that's dedicated to an application. And we know that different people need to be involved. So we know that maybe the engineering team or the capacity planning team need to be involved, whoever those people are, and maybe different business groups that need to be knowing about things. So we need to have really good metadata about our devices. So, in our solution, you've got multiple ways that you can manage that metadata. You've got automated metadata that we're going to derive automatically from what we learn and discover about the devices. You've got manual and managed metadata. You've got APIs that you can be using where you could be managing all your metadata in a central system like ServiceNow or ConnectWise or whatever it might be. And then you've got custom metadata that give you the ability to, all the standard data that we've got, we're really happy with all those metadata fields, but you can make all your own custom metadata if you need it. There's always one or two fields that organizations are using that are a bit special to them. So basically that automated metadata is going to be coming directly from the devices. We're going to poll the devices. We're going to learn things about the devices, and that's available. Then you're going to have your managed metadata where you can go to the GUI, you can just click on things and allocate names to them or whatever it might be, edit the fields. You can use APIs. On a larger environment, you're almost always going to be using APIs to integrate data from other systems, and maybe some push me, pull you scripts that are grabbing data and manipulating it a bit and pushing it out to the devices. And that custom metadata is available to you. So we've talked a bit about the concepts that are really important. And these are important regardless of anything else you're doing. I really encourage you, from all my experience in working and building systems over the years, that really look at those three key concepts for how you can better achieve network monitoring. And they're basically agnostic to the tools, and some tools will leverage them better than others, right? But those are the principles and the concepts that are going to help you be more successful in your network monitoring. So we've got a great feature in our products called Enterprise Services. It's spread across, it's a feature across the products, and it presents itself in one of the GUIs of our main dashboarding tool, OP Charts. But basically, we pull all the data together and we produce the sets of features which we call the Enterprise Service Status Panel. Anytime you can look at a screen and see the status of an enterprise service. An enterprise service here is what I mean is the accounting system, the website, the billing system, the sales management system. You can have a core network enterprise service, whatever that service is, shared or dedicated. You can have an enterprise service to represent it. We'll look at what that might look like in a second. And then now, really important one is that enterprise service impact. When we detect that a thing that makes up the enterprise service is having a degradation or a problem, we'll give you a state thing, it's down, or it's a proactive thing, it's got a problem that you need to look into. The service is up and operating, but it's got it's got a proactive thing that you need to look into. Maybe the disk is getting full and it's impacted a server, so that enterprise service is now degraded. It's operating, it's working, but it needs something else to look at. We provide you with enterprise service topology, so you can see the topology of the enterprise service and understand the relationship between the different objects. And then we've got enterprise service notification. So when we detect a problem in an enterprise service, we generate an alert that's about the enterprise service, and you can decide to send that to who you need to send it to, along with all the other alerts that we might be sending. But the enterprise service notification also involves correlation. So we correlate the events, tag them, and so forth. So it's quite a powerful capability. So let's look at that little sort of network we looked at before. If we had a service provider network and we had, this pretty sort of typical mesh core, and then we had a couple of distribution routers, and then everything here in the bottom left corner, which is some shared infrastructure of that distribution network and one customer router. So we're going to break something. So how does that look in our solution? You're going to get 2 events in our event management system. You're going to get an enterprise service down, which is going to be for the enterprise service for the company. So the element is the ABC company. There's an enterprise service down for this company. That's the dedicated infrastructure for that company that you're monitoring for them. And then you've got a shared infrastructure alert, which is enterprise service down, West distribution network. So now you're going to take these 2 events. One you're going to send to the network engineering team to restore the distribution network, and the other one you're going to send to the customer relationship team and probably the NOC. So now you know what's causing that customer to be down. You want to let them know proactively if you can, but you want to let them know that there's an issue and that you're working on restoring services. Or maybe if the customer's ringing in about the same time all this happens, the team know about the distribution network down, and you've got that impact, that business impact already known. Taking all of those other alerts, all the other things that would be happening are all still in the system, they're available, but these 2 critical events are there to just tell you, the actionable insight of what is going on. Then when you click on that event, so in that event, there's a click, you can click on the event and you can go straight to see, and you get a visualization of what the problem is. You get the events that have happened. You can see, what's going on, and you can drill into this further. And given our time, I think we've got one more slide. No, this is the last picture. So this is you're looking at the events. You can now be drilling in and clicking and finding out what's going on. And for that customer one, you presented that view to the team that's responsible for that customer success, and they can click and see the impact, right? So if they've received that alert, they know that the West network's down, and they're able to tell the customer. So you're really just providing a lot of transparency into the, what has caused the problem. And it's what I call business impact notification. This is root cause analysis, but kind of in reverse. So we're finding what the problems are, we're putting them together and telling you what's impacted. Therefore, when you see the impact, you go straight in and see what caused the impact. There's your root cause analysis. So it's a bit of a mind shift to knowing what's impacted by this change or this outage, whatever's going on. So, concluding what we've sort of just been running through, we've just been looking at the importance and benefits of business-aware network monitoring. We've given a bit of a high-level sort of plan for how you might get started with network monitoring. And we've got those core concepts that support it: the shared infrastructure, shared versus dedicated, reactive versus proactive versus business impact, and labeling devices. And then, we now know how to implement business-aware network monitoring with OP Charts Enterprise Services. So we're going to move on now. So if you're interested in anything there's a few links, and I'm going to hand over to Raleigh, who's got a few questions for us.
Thank you, Keith and Seamus, for those great insights. Keith, let's jump into the questions, starting with you. Why is metadata so important to network monitoring?
Yeah, I mean, the core principle there is, in simple terms, is not all devices are equal. So you need the metadata so that when people are looking at the events and they understand what they are, and that metadata can be include the names of the devices, the groups they're in, the locations of them, all sorts of things about the devices. But it's so that the humans can understand quickly what the device is and if it's important, because not all devices are equal. So when you're triaging all of those events, that metadata is helping you to make better decisions. That's the crux of it.
Thank you for that explanation. Seamus, jumping over to you, you mentioned that NetOps teams aren't happy with how their tools work in the cloud? Why don't they just use cloud observability tools for that?
There are a few reasons. One, they don't know how to use those cloud-centric tools. Two, they might not have access to them because cloud teams often don't work well with NetOps teams. Don't think that the NetOps team has anything to bring to the table. And so why would we let you use our tools? Three, those cloud observability tools have some network intelligence, but not a lot. Quite often you'll hear from people who say that, you know, they get some visibility into the network layer with something that's, you know, used by the cloud team, but really you need a network tool that has visibility into actual networking technology. Like, also, a lot of cloud teams rely on the observability services and capabilities and reporting from their cloud providers for a lot of their visibility. And now that most enterprises are moving towards multi-cloud, those observability capabilities that are native to their cloud providers are siloed. You don't get an end-to-end view, and you also don't get a view from your network of what's happening in your network to what's happening in the cloud. Like, some complaint about a cloud application experience might have something to do with your Wi-Fi network, you know, and you need a network tool that can correlate that local access network with, local area network with what's happening in the cloud to some extent.
Thank you, Seamus. Keith, let's jump back over to you. How long would it normally take to get business-aware network monitoring up and running?
Yeah, we talk about sort of a roadmap to getting, and Seamus was talking earlier about and how it can take months and months to implement a system. But, you know, typically with our solution, out of the box functionality. So, you know, no minimal integrations, you know, LDAP and things like that are very straightforward, but maybe you haven't integrated yet with your service desk. But the out of the box functionality, getting visibility, getting some dashboards up, you're usually looking at a week or two. If it's a smaller environment, it could be a day or two. So you're sort of looking at getting a level of business impact visibility very, very rapidly. And then you're going to do your longer term integrations and, you know, sending data to other systems and pulling data out of things and all that sort of stuff. And we have a broad device support. So we support a lot of devices out of the box. And we have a modeling system that allows you to then extend and collect more metrics or different metrics if not already. And the same system can collect from APIs as it can collect from SNMP MIBs. So, you know, we can cover a lot of, we can be more of that single pane of glass, as a term you don't always use anymore, but we can get more of the devices covered by our solution, and most of it fairly quickly. So usually, even in a large organization, less than a month to out of the box functionality being delivered.
And how can teams become more business aware?
It's a really good question, because engineers love engineering and they don't really think about the business. So I think, you know, it'll sound a bit of a funny answer, but the actual engineering teams of these companies need to meet the people in the business somehow. They need to be aware that the customers, and there's obviously customers that depend on the things that they're doing, and there's people that are delivering and selling services and so forth to those customers. And, you know, you need to have a bit of an ability for the engineering teams somehow, somewhere, to just meet with them, whether it's you know, webinars or session internal meetings over Zoom or whatever it might be. You just need some way that the humans can understand there's other humans involved. And then you probably just want to do a little bit of, you know, business acumen training. I mean, I've done so much of this in my career, but there's a couple of really simple things, but just, you know, do some sort of basic business. You know, how does a business operate? You know, how do you sell something in bottom line, top line? Just really basic business stuff, so that as the engineers are making decisions, they're just a little bit more aware that, you know, this router being down is causing packets not to get delivered, which means that application isn't running, which means the accountants can't put in the end of month things, right? You just want them to understand that there's people and business processes sitting on top of this infrastructure. You know, so it's just, and it's not a straightforward thing. It's just probably just a very light touch, you know, getting them aware of things and talking to people about it.
Thank you, Keith. Let's wrap up with one final question from you, Seamus. What about AI ops? Everyone is talking about it.
Yeah, so AI ops promises service-centric, business-aware network management, promises actionable insights, things like that. AI ops tools, those domain agnostic solutions, a lot of people might be sending metrics and events and things from their network monitoring tools into, are really good at event correlation across IT silos. They can tell you if the network is the problem. They can tell you what part of the network might be causing a problem, or if the network is not a problem at all. But then you're still going to need a good network monitoring tool to solve the problem usually. Like, network management tools are the ones that have the network expertise. Standalone AI ops tools that are correlating things from multiple environments generally aren't going to help you troubleshoot a very network specific problem. On the other hand, you're seeing a lot of network management and network monitoring vendors invest in AI and machine learning to optimize their products to deliver insights around automated troubleshooting and predictive capacity management, smarter alerting, and event correlation within the network layer. That's an emerging area to keep an eye on. And you can talk to your individual vendors about how they're doing that. Like, it starts with good data. You need a network management tool that's really good with data. If your network management vendor has really good data and manages data well, especially if it's pulling data from other tools too and correlating that, then they have a good foundation for like delivering AI-driven network management in the future.
Thank you, Seamus, and thank you, Keith, for all this great information. I wanted to thank our audience for joining us today. As I mentioned at the start of the presentation, you will be receiving a follow-up email from EMA with resources from today's event. So I hope you will check that email out, and I hope we'll see you at a future EMA research webinar. Thank you again for joining us, and enjoy the rest of your day.